Hi everyone, my name is Engineer Shahroz Javed and I am serving as Fire Safety Engineer in Punjab Emergency Service Department, also known as Rescue 1122. And in this session, I will present a segment from NFPA 25, which is the standard for the inspection, testing and maintenance of water-based fire protection systems. Today's presentation focuses primarily on chapter 8 about which is about fire pumps and chapter number 13 valves and valve components specifically we will cover weekly, monthly and quarterly inspection, testing and maintenance requirements. So NFPA 25 is a maintenance standard. Its purpose is not system design, but to ensure that installed fire protection systems remain operational and reliable throughout their service life. So during this session, we will talk about weekly inspection and testing of fire pump systems, inspection and maintenance of valves and valve components, monthly and quarterly ITM requirements for pumps, valves, alarms, and accessories. In this presentation, I will explain not only what NFPA 25 requires, but I will also explain you why these activities are critical from a life safety and system reliability perspective. So now we will move to our second slide, which is about weekly ITM of fire pumps. So NFPA 25 requires weekly inspection and testing of fire pump systems to ensure that they are in a constant state of readiness. So now we will start with weekly inspection of the fire pump system. So weekly inspection of fire pump includes number one point is pump suction, pump discharge and bypass valves must be open because a closed or partially closed valve is one of the most common causes of fire pump failure during an emergency. So the second one point is piping must be free of leaks. So leaks indicate basically leaks indicate corrosion, mechanical damage or failed joints, all of which can reduce available pressure and flow. So the third one is pressure gauges must read normal. So abnormal pressure may indicate obstruction in piping. It may be due to pump degradation and it may be due to valve misalignment. And the fourth point is electrical system conditions must be normal, which includes controller power availability. There should be no alarm or trouble indications, proper panel status, and so these inspections are visual and observational but are critically important. So if we move to our next slide, which is about weekly churn test. So NFPA 25 also requires weekly churn testing, which means running the pump without flowing water. The purpose of churn testing is to verify the pump starts automatically and confirm the driver performance and to detect overheating, vibration or abnormal noise. So if we talk about the churn test duration for diesel and electric pump, so the churn test duration for diesel engine driven pumps is 30 minutes because diesel pumps require longer run times to ensure battery charging, fuel system reliability and engine lubrication, while churn test duration for electric motor driven pumps is 10 minutes. So if we talk about the frequency for churn test, So for diesel and electric pumps, so the frequency for churn test for diesel pump is weekly, and frequency for churn test for electric pumps may be weekly or monthly. It depends on site conditions and the authority having jurisdiction. Normally weekly test frequency shall be required for the following electric pumps, which are as follows, like fire pumps that serve fire protection systems in buildings that are beyond the pumping capacity of the fire department, or fire pumps with limited service controllers. And the most important point is vertical turbine fire pumps. If the facility has vertical turbine fire pump installed, so the churn test frequency will be weekly. And if fire pumps taking suction from ground level tanks or a water source does not provide sufficient pressure, then we will go for weekly churn test frequency. And similarly, a monthly test frequency shall be permitted for electric fire pumps not identified in above points which I talked earlier. So please be noted that you should document and correct immediately any abnormal condition observed during the churn test. So this is all about weekly churn test. Now we will move to our next slide, which is about weekly ITM of valves and valve components. So valves play a critical role in water-based fire protection systems. Before discussing inspection, uh, let me discuss the slide as shown below, which is asking about how many valves do you see. So in left image, uh, we can count that there are 3 valves excluding pressure gauges valves. And similarly in right image there are 2 valves, and you can say that the motor gong is visible in right side image. So in a typical fire protection system, there may be dozens of valves, many of which may be hidden above ceilings, may be located in riser rooms, or may be installed outdoors or underground. So the NFPA 25 classifies fire protection valves based on their function. So now we will move to our next slide, which is about valves and the types of fire protection valves. So there are 5 types of valves which we discuss here. Number one is stop flow valve. So the stop flow valve is because these valves control or stop water flow, such as control valves, main drain valves, inspectors, test valves. So if these valves are closed, the system becomes completely ineffective. So we should make sure that these valves should remain open. And number second is allow flow valves. So these valves include wet pipe, dry pipe, deluge, and pre-action valves. So basically these type of valves allow water to enter the system when activated. And number three is divert flow valves, such as circulating relief valves, pressure relief valves, and these valves used to protect system components from overpressure. And number four is restrict flow direction, which if we talk about examples, which will include check valves, backflow prevention devices, because these valves prevent reverse flow and contamination. And the fifth one is reduce system pressure. So it includes pressure reducing valves, pressure regulating valves, and these valves are used to protect downstream piping and sprinklers. Now, if we move to our next slide, which is about maintenance. So, who is responsible for maintenance? So, NFPA 25 emphasizes that personnel must know what maintenance is required, who to contact when issues are identified in fire suppression system, and what interim safety measures are needed until repairs are made. So if we follow these 3 points, it reinforces that ITM is not just inspection, it is a risk management. So now we will move to our next slide, which is about monthly ITM. So monthly inspections build upon weekly activities and focus on component condition. So we should during monthly ITM we should inspect control valves and ensure that they are sealed, supervised, and are fully open always. And number two is pressure gauges. We should ensure that the ensure and verify its accuracy and legibility of gauges. And number three is valves and trim. So we must have to check valves and trim for corrosion, damage, or missing components. So monthly inspections are especially important in industrial environments, corrosive atmospheres, or facilities with limited weekly access. So this is all about monthly ITM of fire pumps. Now we will move to our next slide, which is about monthly ITM of valves and components. So NFPA 25 requires monthly inspection of wet pipes, wet pipe valves, and dry pipe and deluge valves and pre-action valves, which is mentioned in chapter 13 of NFPA 25. So while doing inspection, the inspectors must verify the correct valve position and ensure that there is no physical damage and there is no leakage or obstruction, or ensure that there are proper supervisory signals are placed. And because why we will inspect all these, because a valve in the wrong position is equivalent to no fire protection at all. So we must have to consider these all points while monthly inspecting these valves. Now we will move to our next slide, which is about quarterly ITM. So quarterly ITM of, if we talk about the quarterly ITM of fire department connection. So fire department connections should be inspected quarterly, because the key points while inspecting quarterly we should take into account includes their caps of FDC should be in place, there should be no obstruction, the gaskets should be intact at their positions, the couplings should be fine and not damaged. And because the FDC is the fire department direct connection to the system. If the FDC fails, manual firefighting support may be compromised. So we should have to be vigilant while performing its inspection. Now we will move to our next slide, which is about quarterly ITM of dry pipe valves. So quarterly ITM of dry pipe valves include NFP 25 requires a priming level test for dry pipe valves. The test should include opening of the priming level test valve, and if water flows, allow it to continue until air is heard, or if air discharges, immediately close the valve. because all these steps ensures the valve is properly primed and ready to operate during cold or freezing conditions. Now we will move to quarterly ITM of supervisory signal devices. So supervisory signal devices must be inspected quarterly for ensuring that there should be no physical damage, there should be proper mounting of devices, the signal transmission capability of supervisory devices, and because these devices are used to alert personnel when valves are closed or systems are impaired. So we must have to be vigilant in performing quarterly ITM of supervisory signal devices. And the next slide is quarterly is about hose houses. So hose houses must be inspected to ensure its accessibility, the structural integrity, there should be no obstruction or damage. To check there should be no obstruction or damage, and because the neglected hose houses often result in delayed manual fire suppression. So we must have to inspect properly for its effective utilization in case of fire or any emergency. The next and the last slide is quarterly ITM of water flow alarm devices. So water flow alarm devices must be flow tested quarterly to confirm the alarm activation, the signal transmission to the fire alarm panel, and the notification to monitoring services. And because all of these steps are needed to ensure that the system is intact, because without this system activation may go unnoticed during an actual fire. So this is all from my side, and thank you for your time and attention. Thank you very much.